We have talked on transpose of a matrix, we've talked about determinant of matrix. And now we want to talk about adjoints of a matrix, and thereafter we'll talk on inverse of a matrix. Okay, so what do we mean by adjoint of a matrix? Okay, now adjoint of a matrix, which is represented as ADH, okay, of let's say matrix A, okay, is the transpose of the cofactors of a matrix. So let's say the cofactor is A, is C, is written as C, as the name implies, cofactors and transpose of it. Alright, so how then do we understand the process of transpose as we have done in the previous lesson? But how then do we evaluate some cofactors of the matrix? Okay, how then do we evaluate cofactors of the matrix? So let's take for instance we are given A, the matrix A, to be A11, A12, A13, A21, A22, A23, A31, A32, A33. And the cofactor, let's call the factor of C. Okay, and we can say that let the cofactor of the matrix be A11, A12, and some people might choose to use C. I think that will be very advisable. C11, C12, C13, C21, C2, C22, C23, C31, C32, C33. Now, in response, we can now say that C11 is the cofactor of A11. C12 is the cofactor of A12. C13 is the cofactor of A13. C21 is the cofactor of A21. C22 is the cofactor of A22. And it follows like that. Now, how then do we now evaluate our cofactor? Now, remember when were doing matrix, determinant of a 3 by 3 matrix, we had our standard, okay, where we say let me say that it is starting with some positive sign at the topmost corner, top left corner, okay, and then we have plus followed by minus, followed by plus, followed by minus, and the order continues that way, okay, plus minus plus minus plus minus, okay, and it continues that way. Now, if we look at this matrix now, okay, definitely we can write it that it is plus minus plus, right, minus plus minus plus minus plus. Remember that the two common signs will definitely not follow each other. Okay, so the next thing we ask is we can erase this obviously. Okay, or move it. Let's move it here. Okay, now the next thing to do after understanding this is where you can now pick a cofactor. Okay, let's start with cofactor of C11. Okay, now if you look at C11, that means we are considering this, right? Just like we did in determinant, we will look at the elements on the horizontal one, we look at the element on the vertical, and we will just have to pick what is left, right? We'll pick what is left. That's A22, A23, Okay, that's 822, 823, 832, 833. Taking the determinants, and notice the sign here is plus. Right? Now let's speak again. C12. C12 is the cofactor of A12. Okay, and when we evaluate C12, we take what is here and we also take what is here. We'll be left with A21 and also A23. A21, A23, A31, A33. And we know that the sign is minus. Okay, now C13 is equal, when we take C13, A1 is the C13 is the cofactor of A13. Okay, so when we take A13, we look at the element on the horizontal, we also look at its element on the vertical. Then we see that we are left with these two, A21, A22, A22, and A31, A32. You can see that the sign on it is a positive sign. So we have positive. Now, then we go ahead and evaluate for the remaining. Okay, so C21. This is C21 here. Okay, I take the values on the horizontal, I take its value on the vertical. Okay, and I'll be left with this, and I'll also be left with this. Okay, that's what the left with is. So we'll have a minus 821 because the sign here is minus. Okay, and 823, 831, and also 833. Now we can go on and on and on like that to evaluate for C22. Okay, and C22 will be plus A11, A13, A31, A33. We do also for C23, and when we evaluate C23, we will left with A11, A12, A31, A32. Remember the sign here is also on A23 is minus, and we do the same thing for C31. Okay, when we take C31, we are considering this, right? So when we consider this on the horizontal, we take that on the vertical, we will be left with A12, A13, and as well as A22, A23. Okay, that place is quite messy, so that's why we are just trying to crumble everything in. Now let's consider A32 now. That's A32. Remember the sign here is negative. Okay, so we apply our negative there. And when we consider A32, look at the horizontal. Okay, look at the vertical. What other values do we have left? So in that case, we'll have A11, A13, A31, A33, and, and C33. That means we are considering this. Okay, and the sign is positive. Okay, so when we consider this as A33, we look at the horizontal and look at the verticals. What are the values we are left with? We are left with A11, A12, A21, and A22. Now, our understanding of determinants, okay, is what will help us to generate the matrix of the cofactors. Okay. Now, once we have been able to generate the matrix of the cofactor, then we'll now just be able to perform the adjoint of the matrix. Okay, with ease, yes, with ease. So now let's take an example. Let's take an example. Considering we give a matrix of A is 2, 3, 5, 4, 1, 6, and 1, 4, 0. And we want to evaluate the cofactors, okay, of C11, C12, C13, C1, C21, C22, C23, C31, C32, and C3. Now, let's evaluate the cofactors of this matrix. Let's start with C11. Okay. Now remember the sign format. Okay. Let's have the sign format written in this column. Remember it is plus, minus, plus, right? And minus, plus, plus, minus, plus, minus, and plus, minus, plus. Okay. So to evaluate C11, okay. Now let's go back. We are considering A11, that is plus 2. A11 on this end, A11 on this end. Okay, now we left it 1640. Okay, plus 1640. Okay, and if we want to evaluate C12 now, okay, which is also minus, which is minus from here. You can see the minus sign there. Now, for that case, if we take it here, take the horizontal, take the vertical, we will be left with 46 and 10. 46 and 10. Now let's evaluate C13. Long blue. Take 5. That's A13, right? A13 is the element on the first row and the third column, which is 5. Validate the horizontal and also the vertical. We'll be left with 4, 1, 1, 4. And the sign is what? Is minus. It's positive, sorry. It's positive. So I want to make everything messy. We have plus 4, 1, 1, 4. Now let's do the same for C23, 2, 1. Well, so C21 we're starting with this. Okay, the sign is what? Negative. Okay, now if we take the vertical and also take the horizontal, we left it 3540. Right, so let's make use of 3540. Right, and let's evaluate C22, and that will give us minus. C22 is positive. Okay, is at the center. Okay, that's positive. Positive. So if we now look at this, the horizontal, the vertical and the horizontal, we left it 2510. Okay, so that's positive, the determinant of 2510. And finally, let's look at 23. Okay, if you look at this, obviously we can see the negative sign, and strike out still a negative, the horizontal and vertical, and we left it what? 2314. The sign is negative. 2314. And let's look at again Moving forward, let's look at C31. C31, okay, which is this. Strike out the vertical, strike out the horizontal. You will left 3516, and the sign on C31 is positive. 3516. I'm looking going further. Let's do 232. Okay, and that's the sign. Strike out the horizontal, strike out the vertical. You'll be left with 2546. Right? And the sign on this is it's negative. Okay, 2516 and maybe 2546. Yep, negative sign. And finally, and C3, which is this. The sign is positive. Strike them out accordingly. Okay, you will have 2341. 2341. Now, after the next thing we will do is to evaluate the determinants on each. Okay, so we'll skip the step and we'll just write out our final answer. Okay, and then to evaluate the determinant, this we will see that the determinant here is minus 24, 0 minus 24. The determinant here 0 minus 6. Okay, and the minus multiplied by the outside, so we have 6. So the determinant here will be 5 or 15, sorry. Okay, so we can take a moment to evaluate each determinant. Okay, so evaluate each determinant. 20, I have minus 5 here, and so we have minus 5 here. 8 minus 3, yeah. And for our last row, we have this one to give us 13, this to give us 12 minus 20. Okay, 12 minus 20 is minus 8. We multiply it again by the minus outside, minus 8. And finally, this to give us 2 minus 12. Right? So 2 minus 12 is minus 10. Okay. So having done that, we will now substitute our values of C11, C12, C13 into this matrix of cofactor. Okay, so we can say that C is C11 is minus 24, C12 is 6, C13 is 15, C21 is 20, C22 is minus 5, C23 is minus 5, C31 is 13, C32 is 8, C33 is minus 10. Now, having done that, we will now go back to the formula of the adjoint of a matrix. Now, the adjoint of a matrix is the transpose of the cofactors. Now, we have been able to evaluate the cofactors of the matrix from C. Okay, this is the cofactors of the matrix. Okay, the cofactor matrix. Then the adjoint of the matrix will be the transpose of this. So we can say adjoint of A is equals to transpose of this cofactor of the cofactor. Okay, now in that case, we'll have it to be, we take the row or the column, anyone, and then we turn it to the other one. Okay, so this will give us minus 24, 20, 13. We take this also, and which is a column, we turn it to a row, as we've done 6 minus 5, 8, and also take this, turn it to a row, that gives us 15 minus 5 and minus 10. Now this is the adjoint of the original matrix A. Okay, so I haven't been able to solve an adjoint. So the process of evaluating the adjoint of a square matrix is very easy. The first thing to do is to evaluate the cofactor at each point, taking reference to these relative signs. Okay, starting with positive at the top right corner, okay, of the matrix. Now the next thing, however, is to evaluate. We can be given to say that we should calculate the inverse of a matrix. The inverse of a matrix. Now the inverse of the matrix is given as A minus 1. Okay. Now the inverse of the matrix is 1 over the determinant of A multiplied by the adjoint of A. Okay. Now let's go back to our question, our original question, where we have A to be 2, 3, 5, 4, 1, 6, and 1, 4, 0. Or we have A to be 2, 3, 5, 4, 1, 6, and 1, 4, 0. Okay, and with this we're able to evaluate the cofactors of A. Okay, and the cofactor is what we have here: minus 24, 6, 15, 20 minus 5 minus 5, minus 24, 6, 15, 20 minus 5 minus 5, and 13, 8 minus 10. 13, 8 minus 10. And with that, we're able to evaluate the adjoint of the matrix A, okay, which is the transpose of the cofactor, okay, which you can read from here. That will give us minus 24, 20, 13, 6 minus 5, 8, and 8, 15, minus 5, minus 10. Okay, now having done that, we've been able to evaluate the adjoint of A. Okay, now the next thing to do is to evaluate the determinant of A. Okay, so without wasting much of our time, we can evaluate the determinant of A to be 2, 3, 5, okay, 4, 1, 6, 1, 4, 0. Okay, and the determinant, after doing everything, we have 2 into 1, so 1, 6, 4, 0, minus 3 into 4, 6, okay, into 4, 6, 1, 0, plus 5 into 4, 1, 1, 4. Okay. Please, if you don't understand what is going on here, kindly refer back to our last video where we talked on determinants of matrix. Plus 2 into 0 minus 24, minus 3 into 0 minus 6, plus 5 into 16 minus 1. So the end will have our final answer to give us 45. Okay, now that we have evaluated our determinant of it, we now come back to our formula. Okay, we can now say that we call that the inverse of A is the adjoint of the matrix multiplied by or divided by its determinant. So we can say that will give us 1 over 45 into, okay, the adjoint is minus 24 20 13, which is this, minus 24 20 13, 6 minus 5 8, 6 minus 5 8, and also 15 minus 10 minus 15 minus 5 minus 10. Okay, now this is the inverse of A. So understanding the formulas, okay, and let's write down the formulas so that we understand better. The adjoint of A, okay, is equal to the transpose of the cofactors of A, and the inverse of A is equals to the adjoint of A with divided by a scalar multiplier of 1 over determinant of A. Now let's take a bit and soak it in. Soak it in. Now we can we can one work on the question. Okay. Now, but because of time, let's say we are given the matrix of A is equals to 2 7 4 3 1 6, excuse me, and 5 0 8. 2 7 4 3 1 6 and 5 0 8, and we are asked to evaluate the adjoint and also the inverse of the matrix. Okay, so to watch our steps, okay, the write the final answer of the cofactor. Okay, the cofactor is 8, 6 minus 5 minus 56 minus 4 35 38 0 and minus 19. It's a long process, yes, but the joy in evaluating it is just cool. Now we want to talk about the determinant of A. After evaluating the determinant of A, you can say that the determinant of A is 2 into 1608 minus 7 into 3658 plus 4 into 3150. Now this gave us 38 after evaluating. Now we know that the adjoint of A is equal to the transpose of the cofactor. Now when we take the transpose of this, we will have what? 8 minus 56 38, 6 minus 4 0, and minus 5 35, and then minus 19. Okay, because the transpose is we are interchanging the rows with the columns. Okay, after evaluating the adjoint of A, the next thing to do is to evaluate the inverse, and the inverse is 1 over the determinant of A multiplied by the adjoint of A. Now the determinant is what? 38, and the adjoint of A is 8 minus 56. That's 8, 6 minus 4 0, and minus 5 35 minus 19. Now yes, the steps wise of this was not given, so I want you guys to solve them, and these are the guidelines to which we evaluate the cofactors. Okay, so we just recollect that cofactor is starting plus minus plus minus plus minus plus minus plus. Okay, so this will guide us to evaluating the cofactors, and you can go back a bit and watch what we did earlier on it, and then to help us grasp a very good understanding on it. And the next thing we'll be talking about will be how to solve simultaneous equations using matrices. Okay, solving simultaneous equation using matrices.